most people think, well, what fills your body is just ordinary water, like water in a glass. And so uh, this water is, we have many experiments now that demonstrate that this water is grossly different, even has a different chemical formula. It's, instead of H2O, it's H3O2. And it has a particular characteristic structure, which, of course, once you know the structure, you know more about the function. And it builds, we found that there are a few interesting features. One, it's charged. It's usually negatively charged. It's not neutral like the water that we drink. And it grows next to certain kinds of surfaces, that is, hydrophilic surfaces, water-loving surfaces, surfaces that hydrophilic means basically water-loving, as opposed to hydrophobic. Like Teflon, for example, is hydrophobic. You put water on it, it beads up. The hydrophilic surfaces, the water spreads out. The surface loves the water, and therefore it envelops the water. The water spreads out, and the two cling together. It's that kind of latter kind of surface. And inside your cells, inside your body, most of the macromolecules that are there are that kind of surface. So hydrophilic. And so this kind of water builds next to those surfaces. And so since your body is packed with those kinds of surfaces, it means that inside your body, most of the water is this kind of fourth phase water, negatively charged, organized molecules like a liquid crystal, and they play a huge part in everything that the cell does. So in terms of charge, if you start with water, this is what we do in our experiments, and your body does this too. So you drink water. I actually just brought some because I get thirsty when I talk.
Okay.
So you drink the water, and this ordinary water gets converted into easy water. This is neutral. Easy water is negatively charged. So if you add electrons to that, you add negative charge. The negative charge should facilitate the buildup of easy water. And you need easy water in the body. Why do you need easy water? Because, or fourth phase water, because every macromolecule in your body is surrounded by this stuff. And if it doesn't have it, or doesn't have enough of it, can't function. There's plenty of evidence for that. In a sense, this is what you already and your listeners know. You need to be hydrated. And hydrated means full of water, but the kind of water we're talking about is easy water, the ordered stuff, rather than the stuff you drink, although the stuff you drink gets converted to it. So if you can add negative charge to ordinary water, we have experiments to show this, you build easy water. So that's something, maybe something for the future, something.
As for the drinking water, you want the water to have hydrogen gas and a lot of electrons. The hydrogen gas is going to like repair your DNA and repair your body, alter gene expression, get everything optimal and functional, put you back into homeostasis. That's what the hydrogen gas does. But the electrons give your body the energy to do that. So you need both. You need a lot of electrons and you need a lot of hydrogen gas. The electrons are going, your body has a net negative charge, so it's slightly alkaline, and it has more electrons than protons. And so what it uses along the cell walls and the mitochondrial walls are just like a little layer of electron-rich water. It's called easy water. So by putting electron-rich water into your body, you're giving it exactly what it uses for energy. Easy water, you're giving it basically electron-rich water, which is what easy water is. It gets all the protons out and has a negative electrical charge. So We're going to test the drinking water of both of these and see what happens. And so you can slow it down to get more hydrogen and a higher oxidation or higher negative oxidation reduction potential, so more electrons. And you can test the hydrogen content with using H2 blue, which you can get it on Amazon. It's like 25 bucks or something. So this, we're going to test the oxidation reduction potential of the drinking water and also the hydrogen content. So this is, each drop is equal to 0.1 parts per million, and alright, this is negative, it's like about 750. So it's a lot of electrons. It's going to give you a lot of energy. It's basically for it's like kind of like recharging your battery. So 0.1, 0.2, 0.3 parts per million. If it turns blue, then that's what the concentration is. 0.4, 0.5, 0.6 parts per million. 0.7, 0.8, 0.9. 1.0, 1.1, 1.2. 1.3, 1.4, 1.5, 1.6. It's as high as you can go, 1.6. So that's what's called fully saturated hydrogen water, and that's a negative 755. So let's see what this other little guy can do. This one doesn't talk. It's telling me to increase the flow. Alright, so see the bubbles of hydrogen gas? So that one makes hydrogen rich water. It's pretty strong too. It's not a negative 750, but a negative 710. That's pretty good. And let's see the hydrogen content. 0.3. That's 0.4. 0.5. That's about it right there. 0.6 it looks like. Yeah, 0.6. There's a big difference in the hydrogen content. It still has a lot of electrons though. But if you're only going to be drinking 1 or 2 cups at a time, you're going to need the high hydrogen from this one. If you're going to be drinking like a whole liter at a time, or like 3 or 4 cups at a time, this is fine. You really only need 0.2 parts per million in order to get the health benefits to kick in from the hydrogen gas. 0.2, 0.3. This looks like it's about a 0.6, 0.5, 0.6, which is plenty, you know. People who drink hydrogen-rich water that's above a 0.8 probably only need about 1 cup at a time. If it's a 0.4, they need about 2 cups at a time. If it's a 0.2, they need 4 cups at a time. You know, 3 times a day, or 4 times a day, or 5 times a day. So yeah, this is the best one in the world. It's digital. It has, you know, it makes water for baby formula and taking medication called clean water. Beauty water for your skin and hair, and also for cleaning, like glass and mirrors and granite countertops, like some wood floors. Use that for the cleaning, and also for watering plants that use its pH of 6. The strong acidic is the one I made before. It makes 2 kinds. It's strong acidic 2.5 or better, and strong common, which is above a pH of 11 for degreasing and cleaning. Drinking water. Use that for cooking. Use that for coffee and tea. It also has a bunch of settings you can do. It also has a mineral additive feature, which you can substitute that in if you don't have enough calcium in your water, but it's not an issue in America. It's more for Japan, where they have a lot of volcanoes and they don't have enough calcium in their water. So there you have it. That's the only ionizer that makes the real hypochlorous acid. The saturated hydrogen water, the high electron water for energy to fuel your mitochondria and your cells and everything. That's what their fuel source is, electrons. So there you go. Get one.